All right, getting started with this today. The last real topic that we have for this course, we're going to have next week to work on examples and review of this stuff. But the quadratic formula is our last big topic. I kind of snuck in working with the quadratic formula into one of the first labs that we did, actually running through the numbers. So you've seen it before. A lot of you have probably seen it before anyway. But you've definitely seen it before in an early lab where it was just a formula written down and we were plugging some numbers into it. Now we're going to see what that actually solves for and why it solves, why we can use it to solve quadratic equations. Um, this perfect square form and this square root property are key steps to understanding where it comes from. And I want to go through the explanation some today. But the good news is you can actually skip a lot of those steps. Once we have this boiled down to the quadratic formula, um, the in-between steps we don't have to do every time because they're all the same except for the numbers involved. So we end up with a formula where we can just work with what the numbers involved are and go directly to the solutions with a little simplifying. And that's what the quadratic formula does for us. So I'm going to explain how that works. Um, Not really going to be on a homework, but I do have some practice stuff out. So if you saw the announcement for this video, the rest of that announcement talks about where the form is for the final exam practice problems that I put out. A review for the final exam, which is, of course, we've got a chapter. It's not the next thing on our agenda because we're going to take a test just on this later material, the chapter 8 and 9 material, the radicals in these equations and the quadratic formula that we're working with now, and how to use that. So we want to practice for that test. That's going to be taken next week during, I'm going to set the time slots for next week on that. And then we're just thinking about putting together the earlier stuff, remembering the earlier stuff that we got to do for this comprehensive final that's going to be scheduled the following week. So I have some times to figure out for tests, but we don't have that much more math to do, just today's formula. So I'm going to get started with that, work some examples, see where this formula comes from and how to use it. And if y'all jump in during the time here, you can drop some questions into the comments here on YouTube. I'll be keeping an eye out for that. So let me know. I'm going to get situated on the paper here. I'll get this started. So topics for the day here. Completing the square is what this process is called, of getting that perfect square form that we like to have. And I want you to see the process, but we're actually going to be able to use this formula to bypass this process. That's the big news. And so the textbook kind of skips over this section of it. I think it would have been nice to have it in the book, but I want you to see where it comes from. But then we're going to see how the formula can actually skip a bunch of these steps and get us right to the solutions to these equations, even when they're not nice numbers. It'll take some simplifying, but not a whole lot of algebraic steps, just simplifying the answers once we get it down. So we're looking at things like, let me get a starting point. I had a few of these I wanted to look at as good examples. X squared plus 10x minus 4 equals 0. Now, this is a quadratic equation. Again, quadratic just refers to the square piece of it. It's got a squared term in it and the other terms of lower degree. And it's already written with a 0 over here as if we were going to use the 0 factor property on it, which is a smart thing to start off with. But the fact is, sometimes things don't factor. This is where we're going to need some other stuff because this one doesn't factor. Right? If I try to think about numbers that'll work in this, there's not going to be a pair of numbers. They'd have to multiply to negative 4, and they'd have to add up to 10, these two terms. Here, would have to add up to 10x. So multiplying to negative 4 can be done a couple of different ways. but none of them are going to add up to 10 or anything like it. So doesn't factor, we can't use zero factor property if we can't factor. Kind of noticed that as we went along. Now we got to wrap that up, the idea of it. How are we going to handle this then? And the answer is the quadratic formula, which comes from this completing the square idea. So I'm going to rewrite that equation with the goal being to use the square root property. So to write this as perfect square equals just number on this side. Make it into a perfect square. And this is a pretty easy one to start with. We're going to see the pattern here, and then we'll apply it to a few others. Kind of reinforce this pattern and see how it leads to the formula we're going to end up with. So if I know I want the number on the other side, I'm going to move that 4 over first, or add 4 to both sides. I already have just x squared here, so that piece looks good. I need a number in here so that when I square this thing out, it would come out to 10x. And thinking about the pattern on these things, this is the sort of the key steps. The main observation here is that this number inside here would have to be this number divided by 2. And that just comes from what happens when we square something like this out, when we multiply something like this out. So think off to the side here. What is x plus 5 squared? Is just x plus 5 times x plus 5. And when you're foiling that out, you get x squared, that's there. And you get a plus 5x and another plus 5x. So that's why the division by 2 in here, those add up to your 10x, sure enough. That 10x has to be split up that way. So this number has to be half of that number. That's always going to work. If I had a negative here, dividing it by 2 would still be a negative. I don't. I have a plus 5. Now the last piece of it here is your last terms. 5 times 5 is 25. So this needs to be x squared plus 10x plus 25. And that's not there. So that's what I have to add to both sides. 5 squared is what gets added to both sides. And that's how I know what my number is. This side is already x plus 5 squared. We're all set with that. 4 plus 25 is 29. That's how I find the number over there. So I do kind of have to work in a zigzag pattern here if I'm going through all the steps on it, which we don't always have to do, but these are the steps involved. Need to get just x squared there, which we already had. You need to divide this number by 2 to find out what's inside here. Square it to find out what's being added. And then when you do that adding up, that's what tells you what's here. There's that little divide by 2 and square it pattern that's going to work on. Really, all of these, once we have the x squared, this might be a little work to that, but that's the process. Once we have that perfect square form, hopefully you're good at this by now. Applying the square root property is what we've been doing on this week's homework. We know we can take the square root of the perfect square, and we're going to get the plus or minus out of that. So x plus 5 is plus or minus the square root of 29. Now, those aren't nice numbers. That's not a perfect square. It doesn't even have any perfect square factors. Doesn't simplify at all. And that's why we didn't find numbers over here that worked, because they weren't nice numbers like that. They were irrational numbers like this one. But that's your solution. Subtract 5 now. We got negative 5 plus the square root of 29, or negative 5 minus the square root of 29. Those are the two values that work on this thing. Those are the two solutions to the equation. And we can always get down to them with pretty much that same routine. I'm going to work a few examples so you can see the process. But ultimately, what mathematicians do when they see that the same steps are going to work on each of these problems, they know they can just boil it down to a formula and skip all of the work because it's predictable then. And that's what happens with quadratics. No matter what kind of solutions you have, the same operations are going to lead to it. So we might as well just make a nice formula out of that. And we will. But let me work through another example on that first. I want you to understand the process on this. 9v squared equals 6v plus 2. Now, if I wanted to try factoring on it, we can solve equations by factoring if they factor. That's not the method that I'm going for this time. And I don't know if this one factors or not, but completing the square is a different process. I want to get, and you can write this down as kind of your goal on the paper here. You want just a number here, and you want your perfect square on that side. Variable's v this time, so I want just to be v and something in here. So I know I want just v squared, and I know I want just numbers on that side. So I am going to move the 6v. I'm going to write it this way. Subtract 6v from both sides, so I got just a number on that side. But I don't have room for this 9. That's what's different about my second example here. 9v squared is not going to turn into just v squared. Well, it is, but I have to do something to make it into that. Essentially, if you have a number sitting here, you have to get rid of that first by division. So there's an extra step here with this 9. I have to divide by 9 to get rid of that. And I have to do that to every term on both sides. Keep the same solutions to the equation. This turns into v squared minus. Now 6 over 9 is 2/3. But I have a fraction there, which is a little bit more work, but still going to follow that same process at this point. I wish I'd left a little more space, but my steps here are divide by 2. So negative 2/3 divided by 2 is negative 1/3. That's the inside number. Square it. Negative 1/3 squared comes out positive 1/9. That's squared. It's always going to be positive. So you're adding something to both sides every time. But you don't really have to carry out the addition here because this is already your perfect square thing. It's already equal to that. This side is where we actually do the adding to see what we get here. 3 over 9, which is just 1/3. So we got v minus 1/3 squared equals 1/3. Now I'm ready to use my square root property and solve this out. That's the process here. Plus minus the square root of 1/3. So the square root of this would be plus or minus the square root of 1/3. V minus 1/3 is plus or minus the square root of 1/3. Now that, I got some simplifying to do on that. That's the deal with these. The first example I did, I had square root of 29. That didn't simplify. This one, I don't have, well, I do have perfect square on top. I have a number on the bottom, so I'm going to have to do the simplifying on this. Keep this around. Squared's gone because I took care of that. Simplify this radical, but that's 1. Square root of 1 is just 1. The square root of 3 doesn't simplify. I'm going to rationalize the denominator. That was our third piece of simplifying radicals, is we want to write that without radicals in the denominator by multiplying by that copy of it, right? Square root of 3 on the top and bottom. This is where we put that idea to use. This is going to be just plus or minus square root of 3 over 3. And then I have to get the v by itself. So solving for that, I got 1/3 plus or minus the square root of 3 over 3. That's what the solution ends up looking like. Or if you want to separate it out, that plus or minus really does represent two different things. We got 1 plus the square root of 3. We got a common denominator now, so I can put that together. Or it's 1 minus the square root of 3 all over 3. That's a nice way to write it out, those two separate pieces. If you want decimal form, you can work out the actual values that comes out to. That would be kind of nice here. I got either 1 plus the square root of 3 divided by 3. Comes out to less than 1. Or 1 minus the square root of 3. Whole thing divided by 3. I have to be careful with the parentheses there. The whole thing's over through that long fraction bar. I have to use parentheses to make sure that's grouped right. That one comes out negative. That is a negative number. Those are the two values that'll work as the solutions to this original equation. I don't really have to check them in the sense that we're not going to have extraneous solutions or anything weird here. If you do the steps right, you're going to, both of the numbers are going to work. So you can check it, but it's not really one of those mandatory checks because we didn't do anything that's going to lead to extraneous solutions on this. The two numbers will both work in the original equation. Now, if you're solving some kind of application, if this was supposed to represent a side length of something or the weight of something, then a negative number might not make sense in the physical situation. But in the equation, that negative number will work. It will make the equation true. So they're both solutions to the equation. You got to think about your physical situation maybe. All right, there's one other thing that can happen here that didn't happen with this example. So I kind of thinking I should go through one more of these. I'm going to use some easier numbers. I'm going to work through one more full example on this. See what else might happen here. (2x squared plus 16x equals negative 40). Again, I want to make this a perfect square form with a number here. This is just going to be x here. This I have to figure out. If I'm just going to get x squared, I can't have the 2. So the first step is dividing by 2. The way my terms are arranged is nice for this, but I have to get rid of that 2 by dividing first. This one didn't come out to a fraction. That's a little nicer. And then see what happens on this. Divide by 2 and square it. And that's what you add here. So divide that by 2. Square it. That's what I add to both sides. Is a positive 16. And this comes out to a negative 4. So there's my zigzag step where you really have to work back and forth between two things. But you see I'm doing exactly the same thing. The numbers that are on these terms is the only difference. So we ought to be able to get the solution to this thing in terms of just some number here and some number there and some number term. That's what we're going to do in general to get the equation out of it. But this one can come out complex. That's what's different about this, is it involves the square root of negative 4. So x plus 4, well, plus or minus square root of negative 4. So in simplifying that radical, we can have different things happen, including complex values, because the square root of negative 4 is not a real number. It's got that negative 1 times 4. So it simplifies to I times 2. X plus 4 is plus or minus I times 2, or plus or minus 2I, and then subtract 4 from both sides. We have x equals negative 4 plus or minus 2I. And those are complex numbers instead of real numbers, but they're still solutions to the equation. There's still two different solutions, negative 4 plus 2I or negative 4 minus 2I. They're complex numbers that are still the two solutions to the equation. So if you end up with a negative here inside the square root, then you've got complex number solutions. And it's not that much different. It's a little different simplifying. Now, what I'm going to do here is what we call deriving the quadratic formula. I've done enough for the pattern to think that, hey, if I got the numbers that are on these different terms, I should be able to predict where this ends up because the steps are predictable. So the way the mathematician would think about it is try to do this in general. Let's just solve all of these problems all at once. because they're going to have something times x squared, something on an x term, and then a number term sitting there. That's what these things look like to begin with. The only difference between any of these quadratic equations is, well, maybe they're arranged a little differently, but essentially they have different numbers sitting there. I'm just going to do it with letters sitting there so I can solve all of them all at once. I'm going to get a formula out of this. It's going to look a little crazy. It's going to a little alphabet soup working through this because I got all these letters going around. But I want you to see where it ends up and where this equation comes from. And then when we're actually solving equations, we can work with just the formula that we end up with out of this instead of having to think through all of these steps. So I hope from going through it that the steps kind of make sense and you see how it works. But I imagine also from going through it, you think that's a lot of work. That's kind of some cumbersome steps in there, a lot of opportunities to make mistakes. Well, we're going to bypass a lot of that with this formula. So see what happens in general. I know I want the number on the other side. So I'm going to subtract c from both sides, whatever's here. You see, I'm going to subtract c from both sides. And then I know I want this to be just x squared, so I want to get rid of the a. We divided everywhere by that, right? We've done that a couple of times. Ends up being a fraction on this. But that gives me just x squared. That's nice. b over a x. And on this side, we got negative c over a. Now the steps in here are the divide by 2 and square it things. This is going to be dividing by 2 here, division by 2. Well, it's b over a divided by 2, which is dividing fractions means multiplying by the reciprocal. So I got b over 2a. That's the value inside here is b over 2a. And then I'm supposed to square it for this piece. So my little arrow is reminding me of the zigzag thing, and then I can add this up. Squaring that, now I take this number and square it. So b over 2a times itself comes out b squared over 4a squared. So that's what I need to add to both sides, is plus b squared over 4a squared and this maybe reminds us of how to add fractions here. We're going to have to think about how to add these variable expressions. When there's denominators, we need a common denominator to do that. So a little extra work there. I got to make them a common denominator of 4a squared. So this one's going to become, well, I got to multiply by 4a on that. I'm going to squeeze it in here because I didn't leave myself a lot of room. But it looks like my camera actually felt like focusing a little bit today. So that's good. Multiplying by 4a on that, I got negative 4ac plus b squared over 4a squared. That's my number. That's the crazy looking number that you end up with on that side. I'm going to apply the square root property, but let me neaten up what I got so far here just a little bit first. So I'm going to do the square root of both sides now. I'm going to rewrite this one because I have the minus term. I'm going to rewrite that as b squared minus 4ac just to have the positive term out in front. And it's plus or minus the square root of all of that. Now that means x plus b over 2a is plus or minus this radical, and I want to simplify it. Good news is the bottom 4a squared is a perfect square. So the square root of 4a squared is just 2a. That's good. The bad news is the top doesn't really simplify. I got unlike terms in there. I don't have any simplifying I can do on that. So this piece stays b squared minus 4ac. That's as good as I can do on that. And then I get x by itself. So I'm subtracting b over 2a or x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And just like we saw in the last example, in that fraction example, they do have a nice common denominator at this point, so I can put the whole thing over that denominator. I got negative b plus or minus the square root of b squared minus 4ac over 2a. And whatever a, b, and c you have to start your equation, you can drop those numbers into this formula. And the numbers, when you simplify that out, the two numbers that you end up with, you got plus or minus there, so you're getting two values. Those are going to be the solutions to the equation if you simplify it right. And don't make any mistakes with the calculations. That will work out just fine. So let me go back to one that I already did, see how this looks on an example that I already did through all the steps. We're going to skip the steps on it now. But right underneath here, we have how this worked out for this one. I'm just going to cover up all that work and think, how would I do this if I know this formula that we have to work with now? Well, the thing I got to notice is that I want to get my a, b, and c from this form. So I want all the terms on the same side to start with. So if I'm starting with 2x squared plus 16x equals negative 40, I'm going to move that and make it a plus 40 on that side, so I have the 0 form. Now I've lined this up. I know what a, b, and c are. I know a is 2, b is 16, c is 40. I'm going to skip all of that weird rearranging stuff in there. And I'm going to go to the formula and just drop those numbers into it. So I'm going to copy this formula right up here next to what I got. This is the outcome of all of that. All I have to do is drop those numbers into the containers in that, and we've got our solutions. So this is 2 times 2. This is the opposite of 16, or negative 16. And inside here, I got 16 squared minus 4 times 2 times 40. And those are my solutions. I just have to simplify that as much as I can. Right here, I got a bunch of calculations to do inside. That's where most of the work is. But if you do 16 squared minus 4 times 2 times 40, let's try it. 16 squared minus 4 times 2 times 40. That's not too bad, but you get this value out of it. That's what's inside the square root is negative 64. That's where most of the calculations are. And then you're thinking simplifying radicals and stuff if you can. 64 is a perfect square. Negative in there means I have the I. So this kind of simplifying would be, that just turns into I times the square root of 64. So 8i is what I get as negative 16 plus or minus 8i. Since these are both divisible by 4, I can write that negative 16 divided by 4 is negative 4. 8 divided by 4 is 2. So I got negative 4 plus or minus 2i. That's the same values that I ended up with when we did it by completing the square. That checks out okay. Those are the values. But I did that with very different steps. Getting the x by itself right away, all of the work is really just simplifying this expression down. So that deal about simplest radical form that we did, mostly with numbers, we're going to use it here. We did a bunch with variables in there, but you're not going to really have letters in there. You're going to be dropping numbers in for A and B and C, and you're going to get square root of some number in there. Could be a perfect square, could have perfect square factors, could be a negative that leads to these I things, but you do your simplifying on that radical, and you got your simplest form of the solutions to that equation, and that'll work on all of them. You're just going to have different values for A, B, and C on different equations. So that's what we want to be able to do. The end of this whole process is solve any of these. Now, if it did factor, factoring, if once you're good at it, is easier than this stuff for nice numbers where they factor nicely, but a lot of them don't. And since, well, if they don't, then this quadratic formula is a pretty quick way to handle things. Factoring only looks for nice numbers. If it factors, you got nice rational number solutions. Most of these, of course, have irrational or even complex solutions. So most of them aren't going to factor if you just make up some numbers. Probably you need something that doesn't factor, but this quadratic formula will do the job. So this is what we want to come back to. Let me work through one with some other numbers just remembering this formula now. If I start with where 3x squared equals 5x minus 7. Let me go plus 7. I want to make sure it has real solutions this time. We already did one with I. I want to have one that has real solutions, but I'm pretty sure. Well, yeah, this one will have real solutions. So moving everything to one side should kind of come to mind because that's what we did with zero factor property. We had to get our 0 first, right? So I want 0 here, so I subtract 5x and I subtract 7 and I get 0 on one side. And then I try to factor it, but you're going to find out this one doesn't factor. So if I take a minute and write this down, I'm getting a negative 21. 3 times negative 7 is negative 21. I need x terms that add up to negative 5. And this is kind of close to that, but none of them are going to work, right? Those are not going to add up to negative 5. Kind of close, but not quite. Doesn't work. Does not factor. This is prime. Okay. I'm ready to go with my quadratic formula then. Once I recognize it doesn't factor, I just take the numbers I got there. This one's A. This one's B. It's important you have them in the normal descending order because you got to know which is which here. A comes from your x squared term. B comes from the x term. C comes from the number term that's there. Doesn't include the variables. It's just the numbers of what we call the coefficients of each term. Those are the values that you're plugging into the formula. 3, negative 5, negative 7. So drop those in. I'm actually going to write this formula out with just the containers in it now. The more you look back at this formula, the more you put it to use, the more you're going to remember on that. So you want to have this formula memorized going on to algebra. We use it all the time. Any equation that has these kind of terms, this will apply to. So we want to get used to using this. Dropping in different numbers here. But the B, this number is B, and this number is B. The A goes here, and the C is over here. So this is B squared minus 4AC. This is your 2A. This is your, it's negative B, but B is already negative in this one. So that's opposite of negative 5. That's going to end up a positive 5. This is 2 times 3 is 6. This is where the serious calculation goes on. Now, I punched in the calculator last time, but it's not that big a deal to do these calculations with numbers like this either. So let me write this, just do it on paper this time. Negative 5 squared is 25. You're always squaring something here. It never ends up negative when you square things. The container is important there, but this is negative 5 times negative 5 is 25. B squared always ends up positive. This part you might have different signs over here. This time I got 4 times 3 times negative 7, which is negative 84. But it's minus a negative 84. which is really just adding the same as adding positive 84. So we are going to end up with a big positive number this time. Most of the work's inside here. 25 minus negative 84 is the same as 25 plus 84, which is 109. Square root of 109. Most of the work's inside that radical, and this value that we end up inside here has a special name. This is called the discriminant. Now, I'm sure you weren't just sitting there wondering what the name is for that, but we call it the discriminant because it's what helps us separate out the different kinds of things that can happen here. If we get a perfect square number, this will come out nice rational numbers. If we get a negative, we've seen that means we end up with complex numbers. In this case, it's not a perfect square, but it's positive, so we're just going to get irrational numbers, numbers with radical. We're stuck with the radical. In fact, 109 doesn't even have any perfect square factors. You can't take out a 4 or a 9 or a 25 or anything like that, so it doesn't even simplify any further. Those are your solutions, irrational numbers. 5 plus the square root of 109 over 6, or 5 minus the square root of 109 over 6. For regular algebra solutions, we want exact solutions, so I'm not going to put these in the calculator and get decimals out of it. I want to keep them exact and not approximate. So I'm not even going to do that most of the time. Now, if this was supposed to be solving for something in a physical situation, if this was going to be my velocity or the side of a rectangle or something, then I would want decimal values that work, approximate values. But for regular solving an equation, we want to stick with the exact values on it. That's really what we're concentrating on. If you're going on to the next algebra class, you're probably going to see a lot more applications. They're either business applications or technical applications of this, where the decimals would be more useful. That's calculator work. I don't want to take the time on it now. I'm trying to concentrate on the process of using the quadratic formula. So this kind of thing, it might just say solve, but it might actually say solve by using the quadratic formula.
I know, right?
And it's the easier way to solve these things when they don't factor like this one. This is the easier way to go. So a lot of the equations that we did in earlier chapters, we had to doctor them all so that they would end up something nice. After the initial steps, you had to come out with something that factors. We had to sort of carefully select problems for the book that didn't need this formula because your factoring would work all the time. So you might have gotten kind of a misconception going through that when you get rid of denominators and stuff, you should always get something that factors nicely. That was a little stalling tactic because we worked those problems to get that process. And now we're looking at what happens when they don't factor. We can do all of those now. So I'm going to go back to one that doesn't have nice solutions here, that use a technique that we used earlier, but see how it applies to this kind of thing if the solutions aren't so nice. So let me find one that works out kind of weird. These are irrational solutions to this kind of thing. Okay. I could even go like, yes, it's good. Solve this. It's 1 over x plus 3 over x squared equals 2 over 5. So if you remember, everything that we did all semester, then something's going to come to mind right here. This wasn't that long ago. Actually, this piece of it, we're solving an equation that has denominators in it. So it's only going back a couple of chapters. Solving equation involving rational expressions, something with denominators. And if we had denominators in there, we wanted to get rid of them. So our technique was to spread this out and multiply everywhere by something that would get rid of all these denominators. And then it always magically ended up nice, and this one won't. But we're gonna go through the process and see how this ends up as a quadratic. But my denominators are x and x squared and 5. So the common multiple of all of those would just be 5x squared. That already has a 5 and an x squared as a factor, but it also has x as a factor because x squared is just x times x. So that's what I want to multiply by. That's my common multiple here. So write 5x squared next to everything, and then get rid of the denominators. Pointless to get rid of the denominators. 5 is gone. X squared is gone. X goes into x squared, leaves an x on that term, so we're going to have 5x here. 1 times 5 times x, 3 times 5, and 2 times x squared. So we ended up with an x squared term, an x term, and a number term. Ends up as a quadratic. And it's one that's not going to factor. So when we were doing this before, we would move everything to one side and try to factor it. We still want to move everything to one side. I'm going to pick the right side because I like my x squared term positive. It's a little easier. So I'm keeping this here. It's going to be a minus 5x and a minus 15 on that side of the equation. And if you're good at factoring, you can give this a try, but you're not going to get anywhere. Right? You're not finding numbers that work there because there aren't any. So it doesn't factor. There's nothing that multiplies to negative 30 and adds up to negative 5. Not quite. So still want this form, the 0 on one side. Identify your values from there. That means A is 2, B is negative 5, C is negative 15, and we're going to drop those into the formula. Solving for x is sort of done right here. 2 times A, it's opposite of B plus or minus the square root of B squared minus 4 times A times C. So I'm writing them empty, and I'm going to drop the numbers in there. If you write the letters in there, then you got to rewrite it again with the numbers. You should write it. You get used to where the letters go, because this formula is, in the grand scheme of things, it's one of the more important things to remember going forward because it applies to so many kinds of equations. We use it all the time. This, by the way, I usually take a little time on this, on the history of this. I'm not an expert on it, but I know this formula was known as far back as ancient Egyptian and Babylonian civilizations because of the geometric uses of it in rectangles and triangles and stuff. It wouldn't have looked like this back then because they didn't have the algebraic notation that we have now, but the basic process and the outcome of that process and how to find these values was known all the way back then. So it's pretty ancient. A, B, and C is your standard lettering for it now, modern times. The A is the value that goes here and here. This was where A goes. The B is negative 5. That's here and here. And the C only shows up right here. This is B squared minus 4AC is your determinant. We'll see how that ends up. I got to be careful about how long I draw these lines because this whole thing is divided by 4. People doing this on paper, the tendency is to have that over 4 part drift and become part of only part of it, but it's not. It's the whole thing divided by 4. So I got my 5 plus or minus the radical all over 4. Got to be careful about that. The work inside the radical, I got to do that work. That's positive 25 minus negative 120. 120, yes. But because that's minus and negative, we're going to add a positive. So 25 minus negative 120 is a positive 145. I'm making kind of a big deal about that because it's really easy to make mistakes with that. With the signs in there, mistakes with negatives. We've been doing that all semester. Got to be careful with your signs when you have subtraction. It's adding the opposite. 145 is not a perfect square. It's very close to, well, 12 squared is 144, but it's not a perfect square. It doesn't even have any perfect square factors. If you try to divide that by 9 or 4 or 25 or 36 or none of them come out even. So this one doesn't simplify any further than that. It's just those numbers. I want to go through the calculations on this because you should see a decimal form of this sometimes. So that's the exact form. And I'm going to go ahead and calculate the approximate form of both of them. And we got to be careful there too. So those are the exact solutions. And it's easy to lose track with this convenient plus or minus notation. It's easy to forget about the fact that that's two different things. Plus and minus, of course, are different things. And we end up with two different numbers out of this. So those are the solutions. I'm going to go ahead and do approximate solutions by calculating this and rounding. And that's where the plus and minus have to be done separately. So get a calculator. That's how we do square roots. We're doing 5 plus the square root of 145. There's no plus or minus in the calculator, right? You got to do them separately. 5 plus the square root of 145. Notice I'm getting that answer and dividing the whole thing by 4 because it's not just part of it divided by 4, it's the whole thing divided by 4. So be careful about that. Whole top comes out 17 point something. So dividing by 4, it comes out to about 4.26. That's one solution. And then do the same thing with the minus. 5 minus the square root of 145 comes out negative. Divide that by 4. You get negative 1.76 approximately. So those are the two values that should work approximately in that equation. They should work out in the original equation. You can actually numerically check that if you're into that kind of thing. It's nice to see that these things actually work sometimes. So if I go back up here with my value, I'm just going to do the negative one. I'm going to check one of these. Negative 1.76 was my approximate x value. So checking that in the original equation would look like, I'll be able to be careful here. I got a lot of work to do. Careful with order of operations on that. But 1 divided by negative 1.76. That's 1 over x. Add that to, and I'm using parentheses to make sure these fractions have the right order of operations here. That's 3 over negative 1.76 squared. That's my other fraction. What do those add up to? Approximately 0.4, right? 2/5 would be 0.4. So the other side of the equation is exactly 0.4. This one was very, very close to 0.4. That's what I expect to happen with rounded solutions, is I expect the two sides of the equation to be approximately the same number. So that was good. That worked for that. I don't care what the 0.4 is in terms of the equation. I just know that answer worked. Negative 1.76 works. And you could check the other one. It also works out fine. They're both going to work. So that's how we find solutions to those. So that was a little bit of review of an earlier chapter there. That was chapter 7, equations. We handled some basic ones like that we could solve by factoring, but now we can handle anything in that form. If it ends up a quadratic, we can handle it whether it factors or not. That's where we're at now. And that's really where this course ends up, is taking equations like that and working out the solutions in either exact or approximate form, something that you can write as a quadratic with a little work. That's the last kind of topic that we have. There is some well-known formulas that are that sort of thing. I mentioned the gravity one. Talking about applications, last time I mentioned when something's falling with gravity, that it follows one of these quadratic things, because that's the acceleration due to gravity. If something goes up and back down, that's one of these equations. It might look like this with the time that it's in the air. If something's launched upward at time 0, and gravity's pulling down on it, it'll follow this kind of a path. Earth's gravity, if you're in feet, if you're measuring height in feet, equation would look like this. The function would look like this. F of t is negative 16t squared plus 30t plus 10. Now, the 30 is your initial speed. If something's going up at 30 feet per second when you toss it up into the air. So we're taking a ball, starting at 10 feet above the ground and throwing it up at 30 feet per second. And our function is the height here. So we're starting at 10 feet above the ground. It's going up from there, and then it's going to come back down. So this could be a shot in basketball as it comes off from the rim. It's a missed shot. It hits the rim 10 feet above the ground, and it goes flying up into the air. But it's not going to keep going up because gravity pulls it back down. Right? It'll follow this kind of path. And if you want to see how long it takes, it'll follow this formula pretty closely, because air resistance doesn't have much effect on a basketball. So it would be very, very close to this formula that would follow what happens 1 second later, 2 seconds later. Those would just be t values. So we could ask these kind of questions. What's the height after 1 second? And that's t equals 1, so that's just doing f of 1. You see what happens when t is 1 by plugging a 1 in. Negative 16 times 1 squared plus 30 times 1 plus 10. We got negative 16 plus 30 plus 10 is 24. Yes, 24 feet. Okay, so this one came off the rim really, really fast and went way up into the air. But if we keep going, it's going to come back down. Right after 2 seconds, I don't know when it comes back down exactly, but it's not going to keep going up forever. It's not going to take long. And that's because of this negative on the acceleration part. After 2 seconds, we got negative 64 plus 60 plus 10 comes out just 6 feet. So after 1 second, it's way up in the air. After 2 seconds, it's already back down. Now, if this is on the court somewhere, it's pretty likely somebody's going to grab it before it gets back down to 6 feet. Right, we're down below the rim over here at t equals 2. It's already on its way back down. Somebody's probably going to grab it by then. But the quadratic formula comes in when we ask a different question. When does it reach a height of 9 feet? Same basketball coming off the rim, going up super fast because it bounced high. When does it reach a height of 9 feet? Right? If it's short people that aren't super athletic like most of us, our best hope to get this rebound would be to be there when it gets to 9 feet or so. That's where we're going to try to grab it. So that's going to be, well, let's see what happens. When does it reach a height of 9 feet? Well, my function is still f of t equals negative 16t squared plus 30t plus 10. But I'm not looking at f of 9 here. 9 isn't a t value. I'm looking at when the height or the output is equal to 9. So height of 9 feet means f of t equals 9. The output is 9. So I'm trying to solve this equation now. I'm trying to see what t is when this whole big thing comes out to 9. It's an output question. And I have to solve for t now. And it can because it's a quadratic. I can see when that happens. Now, if you're looking at the picture and what we did already, you know it should happen a little bit before the 2 seconds. It's lower than that by the time we get to 2 seconds. So let's see what happens on it. This equation is quadratic. It's got a squared term, a variable term, and a number term. Extra number term, but those are going to combine. Right now I want to get a 0 on this, so I'm going to subtract 9 from the number terms and combine those like terms. I got a t squared term, I got a t term, I got a number term. Probably doesn't factor. I'm not even going to try here. I'm going to use the quadratic formula on this. So I'm identifying a, b, and c out of that equation, and I'm going to drop them into this formula that says x, well, it's not x equals, it's t equals in this one because that's the variable I'm solving for. Opposite of b plus or minus the square root of b squared minus 4ac. You might be memorizing it already. It's over 2a, the whole thing over 2a. Drop the numbers into it. B is 30. That goes actually in the first 2 blanks. A is negative 16. That goes on the bottom and here in the middle. And C goes right here. So times 1. See what happens with this. Got the easy calculations. I got this is the more complicated calculations inside that discriminant part. But that's 900 minus negative 64. So that's actually positive 964 that we end up with inside there. It is positive. We are going to have a real number here. We're not talking about imaginary time. That's good. It is going to happen. We want to see what that comes out to. What those come out to, I should use plural there because there is that plus or minus going on. So now I don't know if 964 has any perfect square factors. Okay, sorry, I kind of do because it ends in a 4. It's probably divisible by 4, but 64. It's probably divisible by 4, but I'm not even going to worry about that because I want t values. I want the approximate solutions to this thing. So I'm just going to work through the calculator. I'm just going to put that in the calculator now. Simplest radical form would come out to the same value anyway. I might as well just do it from negative 30 plus the square root of 964. Don't put the division in here now because you want to make sure that whole expression is divided and not just the last piece of it. So let's get the result. This is the whole numerator now. Comes out to that. Divide it by negative 32. Wait, what happened there? That's positive. Divided by negative 32. Comes out negative. T is negative 0.03. This model doesn't actually deal with negative time. We're not going backwards in time because we're only looking at what happens after this thing comes off the rim. Negative values don't really work. That's what I got when I used the addition was a negative value on this one. Got to try it with the minus. So it's this or negative 30 minus the square root of 964. Oh, I don't even know what that symbol is. Square root of negative 30 minus the square root of 964. Take that result, divided by -32. That looks like the kind of answer we were expecting. About 1.9 seconds. So 1.9 seconds is when we want to be in position for that rebound. That's when it's going to be about within reach. Being able to jump quickly is pretty important for rebounding. We'll grab it about then if we're in the right spot. That -0.3 seconds is if it hadn't bounced off the rim, it would have been on its way up, and it would have hit 9 feet on its way up. But that doesn't apply here. We're only applying a model that started when it came off from the rim. So it only really applies to positive t-values. This one will work algebraically. If you plug this into the function, you get 9 feet for the height, but it doesn't make sense in the physical situation. And you're not going to grab it before it hits the rim. You're going to grab it at 1.9 seconds. That's the one that makes sense in the physical situation. So there was a whole application of it, how this applies to a physics situation there. All right, so there's one similar to that in the final exam review. I know from experience in the classroom that once you give out final exam review stuff to people, they have a hard time concentrating on anything else because it seems like working on that final exam review is a big deal, and it is. And so I just put it out there now a way ahead of time. Final exam is not next week, it's the following week. We have to take an exam on chapters 8 and 9 first, but that's part of getting ready for the final, getting practice with this newer stuff. So we have an exam coming up on the radicals and the equations, like we're on the lab this week. And we have quadratics will be on there. So quadratics and other equations that turn into quadratics, that can be rewritten as a quadratic, will be on this first exam. We got a chance to get one more test grade in before the final. People's averages and stuff here, and that'll be scheduled later next week. Probably have like Wednesday night and Thursday exam times. I'll put some time slots out in Monday's announcement for that and get ready for that. One last test. We'll average things up after that, and then we'll have the final exam. The following week, final exams, I believe, are supposed to be Tuesday and Wednesday of the following week. So I'll get some details out about that. But I want to show the kinds of things that can happen here. Now, from this past week's lab, I'm seeing those get turned in, and people are doing good work on those. But I want to jump off from one of those and think about process there and how it ties into the new stuff. Let me pull that up and grab one of the equations that we did on that lab. There was 2 parts to the lab here. One with equations is the one that I want. Here's the properties. Yeah, this is the thing. Okay, here's a good example. Number 11 from the lab.
Okay, anything anybody wants? Fine, what? Anything anybody wants? Oh, yes. Okay, I'll get them here. Oh, no. I think we're good. Okay.
All right. This is the one that was on the lab. I want to see how that comes out, and then I'm going to come back and mess with it and see how it could come out a little different. Okay, so I'm trying to get 2 lessons out of this. This one I think people did okay. The key thing to remember with this equation with radical. So I'm categorizing this kind of problem. It says to solve the equation. It's an equation. What's the most complicated thing in there? It's got this radical deal in it. So that's what I want to get rid of first, is the most complicated thing. The way to get rid of a radical was squaring both sides. But you have to isolate it first. You don't want this whole big thing squared because that would turn into a mess. You want just the radical squared. So that's your first thing to think here. Isolate radical. I want this by itself. I'm not changing the radical, but I'm changing the others. I'm basically adding x to both sides. So I got x plus 6.
Okay. See you later.
Now I'm ready to square both sides and get rid of the radical. And I'm going to make a mental note right here that because I'm doing this, I might have extraneous solutions. In fact, I'm going to make a written note. I have to check my answers because I did this, and it can give you extraneous solutions when you do that. But it gets rid of the radical. This is just 2x plus 5 now. And this, oh, that's x plus 6 times itself. So I got to think through how that multiplies out, right? It's x plus 6 times x plus 6. I've got some work to do on it. That's going to FOIL out to a plus 12x and a 36. That's your perfect square thing right there. And then you're thinking, oh, it's an equation with an x squared, an x term, and number term. It's one of these quadratic equations. We want to get the zero and try to use the zero factor property. So I'm subtracting 2x, and I'm subtracting 5 to get 0, both sides. So I got x squared plus 10x plus 31. That's weird. Oh, I ended up with something that doesn't factor here, which I thought was a little weird. That's because I copied the problem down. So if you're following along with this, you got your lab out, you're saying, wait, that's the wrong number. I actually wrote it down right the first time. That was actually 15. So because I've written my steps out nicely, I can trace this back through and see what happened. That should have been a 15. So when we got rid of the radical, that would have been a 15 right there. So I should be subtracting 15 from both sides. Now that comes out to 21. I like that better. And it's correct. So x squared plus 10x plus 21 equals 0. I want to use my zero factor property. So I'm saying, writing a factored form of that thing and then using the property. Either x plus 3 is 0 or x plus 7 is 0. So x is negative 3 or x is negative 7. And I have this note here that you got to check them to see if they work. So if you go back to the original equation, x equals negative 3 comes out correct. And x equals negative 7 doesn't. It doesn't actually work in the original. So if you got this completely right on the lab, you'd have to throw away your extraneous solution and mark the one that really works. So you got to check those independently. You don't know what's going to happen. In this case, one of them worked. But the other thing that happened along the way here was we were kind of lucky, or this one was kind of set up so that that thing would factor when we get to that point. And if it doesn't, then we're going to have to use the quadratic formula at that point. Right? This was a quadratic. And if it's 10 and 21 and it's easy to find factors of, then that's the quickest way to solve it. But if you add different numbers there, it would be easy to have a prime one there. And that's where the quadratic formula would come in. That kind of equation from chapter 8 would also lead to a quadratic that we'd have to use the formula on if it was one that didn't factor. So let me show you how fragile this is. If I just make one little change to that original thing, it's pretty unlikely to have a nice solution. So this thing, if it said square root of 2x plus 15 was x plus 5 instead of a 6 there. If I had just a slight difference on that, what's going to happen when I try to follow through the same steps on that? So we'll try to solve this one. And I've got the radical isolated already. I'm ready to square both sides of this. Go through that process again. Whole thing squared. So 2x plus 15 equals, this has to be FOILed out now, that's x squared plus 10x plus 25. And my little note here, check answers, because I squared both sides of it. We'll see what happens on this. It's going to be kind of a pain if I have ugly numbers, but let's see what we get. still want the 0 on one side. So the next step is the same. Anyway, I don't know if it's going to factor yet, but I want a 0 on one side. So I'm still moving terms around to get my 0. And this one I got x squared plus 8x plus 10. And then for that's my z. That's my 0. And then for my factor, I'm going to try to factor that thing, but I don't think I'm going to succeed right here. I don't have numbers that multiply to 10 and add up to 8. I got 1 times 10 or 2 times 5. That's close. Close doesn't count here. It's prime. Nothing adds up to 8. So I do have to use the quadratic formula. I still like this form. I'm just using this form in a different way to isolate this out and say A, B, and C right here. Do your ABCs. A is 1, that's 1x squared. B is 8. And C is 10. My x values I'm going to find from my quadratic formula. Again, I'm going to write the containers and the whole form of this thing with the long line. Put your A, B, and C in where they go. A, B, and C. Get used to that. That's the key to the quadratic formula. Writing the big thing out with the long radical and the long division bar, so we keep our order of operations correct on that. That's going to come out. Well, let's see how it's going to come out. A couple of easy things on the outside and a few calculations on the inside. 2 times 1 is just 2. Negative 8 is just negative 8. Inside here, I have some work to do. That's 64 minus 40 is 24. And those are the solutions to the thing, but I should simplify it if I can. And if you're good with these radicals by now, you see the 24 and you think, oh, that's 4 times something, right? I can separate out that perfect square factor. The square root of 24 is radical 4 times radical 6. Perfect square factor comes out nice. The 6 doesn't simplify any further. So I got 2 radical 6. I got x equals negative 8 plus or minus 2 square root of 6 over 2. Now, I got a common factor of 2 everywhere. So I can actually divide out the 2. I can take it out of every term because it's a common factor there. So I could just say negative 4 plus or minus the square root of 6. It's the whole thing divided by 2, so I got to make sure I take it out of both terms. Both of those come out nice. So negative 4 plus or minus the square root of 6 are the solutions to that quadratic. Now, I don't want to miss this. I told myself all the way up here to check the answers on that thing because of that step at the beginning. I don't know if these are going to work. How do I check answers that look like negative 4 plus or minus the square root of 6? I don't want to deal with expressions like that, right? So I'm going to check that out by going to decimal form on these things and check the approximate values of it and see if they work. So let's see what happens. Approximate solutions. You got your exact solutions, negative 4 plus or minus the square root of 6. And you got your approximate solutions, which are still negative 4 plus or minus the square root of 6, just rounded. So I want to see what that is. Negative 4 plus square root of 6, negative 1.55. And negative 4 minus square root of 6, negative 6.45. I'm rounding to the nearest hundredth on that, but wherever you round it, it's approximate. So they're not going to come out perfect, but we want to see if they're even close. We want to see if they're actually solutions up there. So those are the values. I got a calculator on that. They both came out negative on this because you're starting with a negative 4 and you're plus or minus a little thing. So it ends up negative either way, but that's okay. Got to see how it works in the original equation. Some more calculation to do now. Plugging those into here. Square root of 2x plus 15. I'm going to do each side of the equation and see what I get. And this is the square root of 2 times x plus 15. Need some grouping symbols in there to make sure I take the square root of that whole thing. That side came out to 3.445. And the other side of the equation was x plus 5. So negative 1.55 plus 5. Hey, that matches. It doesn't match perfectly, but they're approximately the same, 3.45. So that really is a solution. The negative 1.55 works. The other one, well, I'm going to see what happens with the other one. So I'm going to do that calculation process again. A lot of opportunities to make mistakes with the calculator in here. Trying to be careful. Negative, and I need those parentheses. I almost started without them. The whole thing's inside the radical, so I need the parentheses there. Negative 6.45. 2 times negative 6.45 plus 15. Square root of that whole thing is 1.45. And the other side of the equation is negative 6.45 plus 5. That did not end up the same. Right, this is about 1.45. This one's negative. That's the kind of thing that goes wrong with these extraneous solutions, is if you squared them both, it comes out to the same. But they're not actually in the original equation. They're two different things with that plus and the minus in there. So this one is not actually a solution. Sometimes they both work on this, but sometimes one of them is this extraneous deal. So got to check. Exact solutions would be a real pain to check here, but the approximate ones, the calculator can do that. Plug it into both sides and see if it matches up. That's a lot easier to do with decimal form. So that's one good use of that. All right, we get another week to think about these and also start thinking back to the other stuff that would be on this test. So look at those review things that I put the link to in today's announcement. Get me questions on that. Wrapping up, you're still should be wrapping up the 8th online homework. A lot of people have done that, but that's still going on over the weekend. It's our last homework. I'll have some stuff out Monday on when to take the test and some practice stuff to get ready for the Chapter 8-9 test. And further information about the final, when that's going to be. So I'll get that out in an announcement on Monday. Y'all have a good weekend, and let me know as you work through that review stuff. Let me know any questions that come up that you want to work on.